Okay, hello everyone, and welcome to our next session. This is session number 1, 2, 3, 4, 5, 6, 7, 8 of 24. So this will complete 1/3 of the vJUG24, and indeed this will conclude the APAC region. So today's session, or not today's session, but this session is continuous delivery patterns for the modern Java developer, i.e. all of us. And the speaker who should be on now is Daniel Bryant. Are you with us, Daniel?
I am indeed, Simon. How you doing?
Hello. I'm not too bad so far. I'll be mad pretty soon. But, not too bad. That last session did push me, I'll be honest. But we made it in the end. Yeah, this session is sponsored by Sonatype, and we have our participating JUG, the Abidjan JUG. So I'll be talking with them just briefly. But just to mention, the sponsor is Sonatype, and another Equifax is apparently coming, so you can prevent it, and Sonatype can help. So do check out that site, sonatype.com/software bill of materials with dashes. And do check out what Sonatype Nexus can do for you. Sonatype, obviously, some big community sponsors, and they are our gold sponsors for vJUG24. So we massively welcome Sonatype. And actually, Sonatype, Derek Weeks and a number of other people from Sonatype did a all-day DevOps session, or all-day DevOps conference yesterday. It was an online 24-hour conference. These kind of things must be catchy. That actually finished at 8 a.m. this morning. So I wonder if we'll give anyone a shout out if they are.
And I spoke there, Simon, as well. Yeah?
I saw you'd spoken. Yeah. So if anyone is doing the full 48 hours, we do have numbers you can contact for any professional help or anything like that, or non-professional help, whatever you need. And also, yeah, obviously the Zero Turnaround do sponsor the virtual JUG. So if you want to develop at supersonic speeds with JRebel and XRebel, do go to zeroturnaround.com for more information about free trials and so forth. Right, so Daniel's going to be giving this session. He's going to be taking questions on Slack. I'll be giving them to him from my comfy seat here. If you join Slack via the link, which is on vjug24.com, you can just join the live session channel, and we'll be taking chats and discussions there. Obviously, on Twitter, our hashtag is vJUG24, and make sure you increase the video quality to ultra supersonic 4K DHD, whatever. So let's take a look at who we've got on now. Stop screen sharing. There we go. So we have Daniel here. Hey, Daniel, how's it going? Nice shirt.
Rocking the branding, yep.
Rocking the branding. Actually, what we haven't shown is actually all the organizers have these oops, oh no, have these full onesie suits which are kind of cool, and then we have these awesome vJUG24 shirts underneath. Double branding through and through. It goes deeper than that as well.
You need a hat, Simon. You need like a cap, yeah.
That's right, yeah. And we also have the Abidjan JUG. Are you there?
To show your camera, Nelly.
Yeah, yes, we're there.
Is your camera up and running? That is a slick.
It's a good profile pic, isn't it?
That is a super slick bow tie going on there. Hey, how's it going?
Yeah, we.
So whereabouts is your JUG?
What?
Whereabouts is your JUG? Where in the world are you broadcasting from?
We are broadcasting from a lab here called Joko Labs, straight from Abidjan.
Wow.
So we are waiting who are going to, follow up us from here.
Awesome. Oh, good to have you on board, and we'll take questions from you a little bit later. And
we are waiting. Yeah. We are waiting at least 123 people.
Oh, wow.
Cool.
Awesome. So we should have a good number of people there soon. Excellent. Okay, so without much further ado, let's pass straight over to Daniel, and we can get started.
Awesome. Cheers, Simon. I'll just share my screen, and if you wouldn't mind just confirming you can see at your end, because unfortunately when I go full screen, you can't see much here in terms of Google Is that looking good?
Yeah, that looks perfect, yeah.
Sweet, I'll crack on. Again, feel free to shout if anyone can't hear me at any time. I'm on pretty solid Wi-Fi, but you never can tell. So I've tweaked the title a little bit from what I initially pitched to Simon, but hopefully, you know, same content, same ideas. It is going to be a more conceptual talk, so I'm not going to do much live coding today. To be honest, I'm pretty bad at live coding, so I'll leave it to the experts like Josh Long and so forth. But this one's going to be looking at sort of modern patterns for Java developers, architects, these kind of things as well. And where I'm coming from with this, like architecture these days, we're hearing so many kind of buzzwords around serverless, microservices, nano services, all these interesting platforms popping up like container technology and function as a service. And the promise is, we simply carve our applications up, we carve our architecture up, we put it in a container, we put it in a zip file or whatever, and we ship it. The only snag is, if our application architecture is a bit of a tire fire, what you kind of get, to be honest, is a tire fire in a container, yeah? And this is not a good look in general. And you can see the firefighters in the bottom right-hand corner there. This is kind of what we refer to as DevOps in our industry, yeah? So my pitch today really is, as much as I love DevOps, and I think DevOps is genuinely amazing in terms of shared responsibility, I think continuous delivery plays a big part in DevOps. And therefore, as a Java developer, I really need to embrace continuous delivery to help my colleagues, my colleagues in QA, my colleagues in Ops, my colleagues in the business as well, yeah? I think continuous delivery is a genuine, overused word, but I think it's a genuine game changer. It can really, change the way you deliver software. The key pitch today, 3 things. We're moving from complicated systems to complex, yeah, with these microservices and, all the Spring Boot and Drop Wizard and microprofile, all amazing things, serverless, Lambda, all these cool things. We're moving very much from the Java EE kind of, coarse-grained systems to fine-grained complex systems. And therefore, my role as an architect is becoming, I think, more about technical leadership than it is about coming up with the perfect canonical domain model or crafting the perfect XML schema, these kind of things. And my role now as an architect, I'm trying to encode a lot of our requirements, both functional requirements and non-functional requirements, into a continuous delivery pipeline, because this is the only way these things get enforced. We all know what documentation is like. We all start with best intentions, but documentation is never kind of built, is never executed, or unless you're using something like Cucumber, but in general, documentation is not executed. Therefore, we need to codify our requirements into something that can be executed. And we'll look at a few technologies, we'll look at a few patterns over the next 30 minutes or so. So the guys have already done a great job and introduced me, but this is me. Love getting involved in the Twitters, at Daniel Bryant UK on Twitter, GitHub, Medium, a whole bunch of other places as well. I work as an independent tech consultant here in the UK, plenty of stuff around Europe, in the US a little bit as well. My background, I started as an academic, but then moved into Java development, JavaScript development, done some ops. And I've really seen over the last sort of 3 or 5 years, as I've been working with teams on microservice systems, that continuous delivery is the way to drive change in the technology and the teams. So I'm becoming a bit of an advocate in continuous delivery. Written a small mini book on the left there. You can get that one free thanks to Nginx. They sponsored that. So if you don't mind giving up your email address, you can get that free book for talking about continuous delivery in Docker. And I'm writing a full book as well, which should be out, continuous delivery in Java, should be out, I think, March next year. So that one's going well, but writing a book is not easy. I'll tell you that. It's a lot of fun, but not easy.
Most importantly, Daniel, which animal is that? What kind of fish is that?
Oh, I did look, Simon. It's because they're all endangered species. All the O'Reilly books are, the animals on them are endangered. So you know what? Next time, that's a great question. I'm going to make sure I know. I don't actually know at the moment, but I can't remember, I should say. But I'll look it up for you. So let's set the scene, yeah. Hopefully many of you, as Java developers, as QA engineers, as ops people, you know what continuous delivery is. And if you don't, Jez and Dave's book is amazing on the right there. It's a fairly chunky read, but totally worth it. But, the kind of high-level pitch, it's about producing valuable and robust software in short cycles, yeah? None of this big bang stuff we used to do 5-10 years ago. Small, valuable deliveries to customers, that is stable, yeah? And it's about really optimizing for feedback and learning, yeah? We as developers, we're optimizing for feedback and learning in our tech stack, in our architecture. The business people, they're optimizing for feedback and learning around business goals, yeah? And one thing I will say, some people get super scared with continuous delivery, thinking it means that me as a developer, as soon as I press the button, the code goes live. Doesn't necessarily have to be that. I think that's continuous deployment. You can do that, and it's fantastic if you get it working. But continuous delivery is about enabling that. You don't have to be pushing to live to be, doing continuous delivery. Yeah, don't have to be pushing to live automatically, I should say. Key thing I mentioned is velocity and stability is key to a lot of business success in the modern world. Yeah, regardless of where you are in the world, time to market and producing stable products is critical. And Steve Smith, a friend of mine, or someone I see a lot in London, talks a lot about this kind of stuff, says continuous delivery is achieved when stability and speed can satisfy business demand. That's really important. Yeah, I know many of us watching here, we're developers. Yeah, I'm a Java developer like everyone here, but it's really important. We're building software for people, and it must be stable, as in not crashing, not insecure. Simon mentioned about Sonatype's great work and all this kind of stuff with software supply chains. Must be stable, must be secure, and we've got to be able to do it at the speed the business wants. Yeah. Discontinuous delivery occurs when we don't get stability and speed. And when I heard Steve say this, I thought this is a great quote. Yeah, this is, when we're developing software, back of our minds, thinking about continuous delivery, think about stability, think about speed. That's the key pitch. This is what a general Java continuous delivery pipeline looks like. Don't worry if you can't read all the text. We'll go through it very briefly now. But fundamentally, it shouldn't be a big surprise to many people that we're sort of coding on our local machines, be it Windows, be it Mac, be it Linux. Typically, my team, we get together, we get business requirements, and we're committing into a centralized repo. Might be Bitbucket, might be GitHub, take your pick. We then build on something like Jenkins or Circle CI, TeamCity, Travis, these kind of things. We probably do some code quality analysis, SonarQube, find bugs, all that good stuff. And then we push the actual the artifact, typically the jar or the war, we push it to some kind of repo, like JFrog Artifactory, Sonatype Nexus, all those kind of good things. We then pull that artifact down, we do some QA, maybe we're running acceptance tests using something like Cucumber, JBehave, Serenity, all these kind of good Java frameworks that I use quite regularly, I should say. And then we push through, if we're happy in QA, to staging. And as we go through here on the right, the environments get more realistic. Yes, QA maybe using mocks and stubs, staging perhaps I'm using sandbox environments, and ultimately when I push through to prod, I'm using the real thing. Yeah, if I'm integrating with PayPal, I'm really using PayPal in prod. In staging, I may be using their sandbox, and in QA, I may be doing kind of mocks and stubs and so forth. Key thing I'd like to mention is continuous delivery does not end when you push through to prod. Continuous delivery really ends when your service, your application is retired. And, that doesn't happen that often in reality. So we've got to close the loop on a lot of these things. When something's deployed, we observe what's going on. Now, observability is getting talked a lot about at the moment, and with very good reason. We'll look into that in more detail later. But the kind of key thing here is when we push to prod, we want to sort of feed back to development, feedback to the business. When we develop some functionality, we probably had a hypothesis about it. Did we prove that hypothesis? Did the business, they wanted to see something change in their way the users are using the system? Did we see that through our metrics? Did we see that through the way the system is reacting? And also critically, we as developers, how can we improve the architecture and the operations? Maybe we want to make sure we're being highly cohesive, I should say, and loosely coupled. And we want to, as our application develops, we want to make sure we're not slipping on our target goals. So this feedback loop is critical. Now, if we bring in some containers or some additional packaging, typically when you're looking at microservices, you're looking at serverless or function as a service. You're putting your Java app, your jar, your runnable jar, or your war. You're putting it in a container, or you're putting it in a zip file, or maybe you're putting it even in like something like a VMware image or a Debian package or something. You're putting it in some form of packaging. And if you're using containers, it does change the pipeline a little bit. And if you're using things like serverless, under the hood, it's pretty much containers as well. You can see sort of 4 points I've pulled out here. I've done another presentation that looks very much at continuous delivery with containers. So I've done that one on the vJUG before. So you can go onto the vJUG YouTube channel and check out that talk I did, I think, 6 months ago or so. But for this talk, fundamentally, the way I'm developing now is probably a bit different locally. I'm using serverless. I'm using Docker or something. When I now build my application, I don't just build a jar and a war. I probably build some form of image or maybe a zip file or something like that. And then when I do my testing, I'm probably going to stand things up a little bit differently now as well, because I'm using containers or serverless. And ultimately, what I'm deploying onto is, if the fabric has changed, I'm probably using something like Kubernetes if I'm doing containers. If I'm using serverless, I'm probably using something like AWS Lambda, Google or Azure Functions. Like, the fabric has changed. So we need to bear that stuff in mind, because we should make our development environments as make our development environments as like live as possible. So bearing all that that's the high level picture of where I'm coming from in terms of architecture and continuous delivery. Now, what are the core challenges with modern Java application architecture? Yeah, and for me, it kind of boils down to this, and this is the first pattern we're looking at today. Say I've got 3 applications here. These are 3 pipelines I've built. I happen to be chucking them in Docker here. Now, do I do this pattern, which is typically gated application deployment? I have my 3 pipelines going in. I kind of orchestrate and I rubber stamp, version 1 of the app is these 3 versions of these 3 components here. Check the box, we do some QA, maybe automated, a little bit of manual QA as well, and we push it out and we're good to go. Now, that's one way of doing it. I think that's a great sort of start. The kind of ultimate aim for a lot of people with microservices and serverless is very loose coupling. So our 3 applications, our 3 pipelines here now, what we're really aiming for is independent service deployment. So I can push this application out, I can push this one out, and I can push this one out. And I can do this separately. It might even be separate teams. Yeah, I might be working on the top team. The second pipeline is someone else, and the third pipeline is someone else again. The snag with some of these things is it's often interactions between the services. The bottom pipeline here may be the checkout service, and the middle pipeline may be the stock keeping service or something like that if we're looking at an e-commerce application. And we can't just randomly push new things out into production, because what I do in one pipeline might break another. So a lot of modern architectures, the challenges introduced by these things is the integration. Yeah, and it's not a new problem, to be honest. I'm sure many of you watching are thinking, I've been doing this with business process modeling, I've been doing this with Camel and Spring integration for years, and I don't disagree with you. But it's becoming more popular with many more developers, because many of us are kind of using microservices now where we used to use the good old monolith. So architecture, let's sort of prime this before we look at a few other patterns as well. Fundamentally, when we're building a monolithic app, which I'm sure most people can relate to, I know when I went through college, when I went through uni, I got taught how to build monoliths. At the time it was Java EE, but I also got taught Ruby stuff later on as well. And if you break down a monolith, and I'm taking some great work here from the self-contained systems website I've referenced there, when we look at our monolith, there's always domains in it. There's, the checkout domain, there's the payment domain or something like that, for example, the stock keeping domain, the product domain. There's typically various layers in the actual monolith. There's the UI layer, there's the business or service layer, there's a repo, maybe a DAO, that kind of thing. And within all this stuff, there's kind of modules, components, frameworks, and libraries. Yeah, modules are obviously super interesting in the Java space at the moment with Java 9, but that's fundamentally what goes into your monolith. Now, a lot of us are seeing different patterns popping up now, different architectural styles, things like self-contained systems. And that's basically breaking out your individual domains, and they're fully, like, one system, one application is fully responsible. So say you're building a drop wizard app, you've got the UI integrated into it, and you've got a separate database for this one vertical, this kind of one domain. And typically, to build a fully working system, a fully functional system, you've got multiple self-contained systems. There might be the checkout self-contained system, the product self-contained system, the product browsing self-contained system, that kind of thing. Of course, there's microservices, pretty much like the self-contained systems, except you don't need to have the full end-to-end responsibility with microservices. I see people like MuleSoft talking about different layers of microservices and basically aggregating functionality up through the stack, which is, in a lot of big enterprises, is very interesting. I do recommend building microservices around business functionality if you can. Don't just replace like EJBs with microservices. That's generally not a good look. But microservices can be more fine-grained perhaps than something like self-contained systems. On the flip side, we're seeing things like functions as a service. So in the Java space, a lot of stuff around AWS Lambda working on at the moment. And this is very fine-grained kind of, architecture, very literally kind of functional. If you're playing around with things like closure and all this kind of stuff, that's it at a language level. But a lot of people now are moving from microservices, well, not a lot, but some people are moving from microservices to things like AWS Lambda, serverless, all these kind of good things. So this is a bit of a brain dump slide. Apologies if it is a lot of text here, but this is kind of, many of us now are working either in the monolithic space, maybe some SOA. You can see along the top the different architecture styles. And we're now looking at things like microservices, self-contained systems, functions as a service, serverless on the right. And if you look down on the left, I've sort of put some things like, what is the scope? Like if you're working on a monolith, the scope might be project. If you're working on SOA, the scope is probably enterprise level. And this is a bit of a brain dump. I'll share the slides later on. You can have a read to your heart's content later on. But I want to pull out a couple things. The first is monoliths are typically implemented by a single team. The deployment is pretty straightforward. Once you've done all your continuous delivery and your testing, once you've got that up and running for the monolith, you're kind of good to go, yeah, because there is only typically one pipeline for the monolith. That architecture is quite easy, or relatively easy, to get into a continuous delivery pipeline. SOA is a little bit more challenging. It tends to be sort of centralized management. It's monolithic orchestration of multiple services, maybe via things like BPM or RPC or some middleware, enterprise service buses, message queues, these kind of things. So there you're often building pipelines for individual services, but they're quite coarse-grained services. If we look at things like microservices, the management is very much distributed. You see people like Martin Fowler talking about smart endpoints and dumb pipes. So that's kind of a little bit of a shot against things like ESBs, where they sort of became quite smart. And if we're not careful, we're pushing a lot of application functionality into our ESB, where really we should be keeping that logic in our actual applications that we are writing as developers, yeah. When it comes to the serverless space, it's kind of quite new at the moment. It's very much event-driven, so we're moving away from our RPC, I think, in the serverless space. There's a lot of discussion around choreography. Do you choreograph services or do you orchestrate services? We'll look at that in a bit more detail in a moment. And that affects continuous delivery quite a lot. Microservices are very much based around choreography. You have applications working together in harmony. There tends not to be an overarching centralized control plane where you sort of say, this is exactly how the microservices will all work together. It tends to be more, one microservice calls another, that microservice calls another in order to do its job. Whereas serverless is more like business process modeling. It's more orchestrated. Wouldn't be, fair talking about architecture. Always think about fundamentals. Yeah, regardless of where you are in your career. I personally got a lot out of Uncle Bob's stuff. He talks about clean coding and clean coder in some really good books. When I was doing a lot of Java EE development when that book came out, and he talked a lot about coupling and cohesion. And these things are really important wherever you are in your career. If you're just starting, please do read up on coupling and cohesion. If you're a veteran, 20 years coding, still doesn't hurt to be reminded of things like coupling and cohesion. They are core principles of architecture. And coupling is all about components having little knowledge of other components. There's always some knowledge to actually get work done, but little knowledge. And like we as Java developers typically create interfaces, we create database schemas, or we create APIs like REST APIs, maybe Swagger, that kind of thing. That's where coupling is interesting for us as continuous delivery and people. Cohesion is more around the degree to which elements within a component belong together. So the classic java.util package is a good example of not good cohesion. Java util has become almost a kind of dumping ground of concurrency and a bunch of other interesting things. But really, we should have a package in Java, and we should have an application or a microservice. There should be a kind of single reason to change. And I appreciate scope is quite varied there. But if I'm building a product, say a product service, the product service should not need to change if I change my checkout. In an ideal world, it should be a cohesive service. It should be loosely coupled. Now, this stuff really affects continuous delivery for us as Java developers. Yeah, when we're designing, if we've got a cohesive system or we're designing a cohesive system, it's easier to reason about modules. And this is going to become even more important to us as Java developers with the impact of JDK 9. Java 9 has brought in modules. I'm sure there's many great talks today about Java 9 modules. I'm really enjoying the book actually, the Java 9 modules book. It's fascinating, but now we need to think about cohesion and coupling a lot more at our code as well as we do the architecture level. Loose coupling tends to reduce impact. When we change one thing, it kind of doesn't cascade through to other things. Cohesion in terms of build typically limits dependencies. I'm sure many of us have worked with, say, like a Spring or a Java EE class where we have to inject so many dependencies to be able to get the class up and running just to test it. And that's typically a sign of that class is not cohesive. Yeah, there's so many dependencies because it does many things, and that applies to architecture, to microservices as well. End-to-end testing, good cohesion and loose coupling allows us to orchestrate data easier. When I'm working on monoliths, typically we have to kind of create database snapshots of the whole world to do our testing. So, literally we have kind of pre-canned data, maybe in a Docker container or something else like that. Maybe we're using some of the Liquibase or some other tools like that. HTML unit's another good one. But if we've got individual kind of services with well-scoped databases, we can create sort of pre-canned data for each service, and it's much easier to combine those different data sets than it is one big kind of thing which we have to manage. Deployment cohesion sort of minimizes the number of components in play, and coupling, if services are coupled, it leads to kind of mini monoliths. Yeah, it leads to the kind of distributed monolith, which is the worst of both worlds. You're doing lots of serialization and deserialization over the wire, but you still can't deploy individual services. You kind of struggle often with velocity if you're having to deploy your whole application in one go. I'm not going to talk about observability that much, but it is super important. It kind of warrants its own talk, to be honest. But cohesive services in general are easier to understand. If there's a single responsibility, a single kind of thing it does, you can typically reason about it easier. And again, if something is highly coupled, when something goes wrong, what we say is the blast radius is typically very big. And I've been involved in many, monolith and microservice debugging. And when you've got like a highly coupled system, it's typically a murder mystery. Yeah, something's gone wrong, and you're thinking, crumbs. Well, I see the effects in this service, but actually it's some service, downstream that's causing the issues or whatever. But if we've got this loose coupling, we can typically sort of coordinate and quarantine the areas and quickly dial into where the real problems are. So these are critical things in architecture, coupling and cohesion, and how they relate to continuous delivery. So getting started now, on my local machine, love using things like Docker and Vagrant, particularly as you're moving to microservices, you're moving to modern architectures, sort of loosely coupled architectures. You don't want to be spinning up, say, lots of different IDEs. I've seen some people work with microservices, they're running like 10 versions of IntelliJ locally because they're working on 10 services. Well, really, you should be working on, say, one service at a time and spinning up the other services that you're dependent on in something like Docker. Not only is that sort of a lighter resource footprint, but it stops you cheating as well. If you've got multiple IDEs open, it's very tempting just to tweak code in different services, and you get that high coupling, which is dangerous. Same thing on the right, you can see on the slide, if you're using things like AWS Lambda or Azure or Google Cloud Functions, there's typically a way now to spin up those environments locally. A lot of them do use Docker under the hood, actually. I'm using SAM local quite a bit. It's a bit fiddly with Java 8 sometimes, but it's really cool for, you can basically spin up like a AWS Lambda environment locally on my Mac, and I can spin up like a local API gateway for testing, which is kind of cool as well. But think about these things. Often, where we start developing on our local machine, it actually really impacts the things like architecture and continuous delivery further down the pipeline. So start right locally. Developing and integrating, I saw an interesting Hacker News article talking about microservices and modules, and they basically said if you can't spin up your whole microservice environment on your laptop, you're not doing microservices. And I think that's rubbish. Yeah, I've worked on many systems where I physically could not get the number of services on my machine. And I'm using like typically legacy systems or vintage, money-making systems. Yeah. And I can't. Some of them are running on like crazy monolithic hardware or whatever, old hardware, I should say. So there's no way I can spin that up locally. So I talked about this on a project I worked on a couple of years ago. We were not on the high street, awesome UK website that sells gifts, and they had a Ruby monolith, and we were migrating that Ruby monolith to Java and Ruby and Go, actually, microservices as well. So you can check out the blog post. I talked about some of the challenges sort of integrating things locally. A couple of companies have popped up now and created open source projects that address some of the problems I mentioned. If you're using telepresence, if you're using Kubernetes, I should say, totally check out telepresence. Telepresence allows you basically to connect up to a remote Kubernetes cluster, so you can run in the cloud your main, say, QA environment or something, and you can develop locally one service, and Kubernetes acts as a kind of proxy between the two. So you can debug and everything locally using IntelliJ or any of your favorite tools, Zero Turnaround, all the great tools there. Develop locally, but it appears locally as if you're in the bigger Kubernetes cluster. So totally check out telepresence. It goes both ways. You can do debugging locally, and you can actually look in the cluster via their cool stuff. So well worth checking out. That is open source tool. one of the companies I'm working for, Spectre Labs, we're looking at service virtualization a lot. So if you're looking to do a lot of, say you're working with many dependent services locally, you can use things like Hoverfly, which is our open source tool. You can use Wiremark, you can use Mountebank to often record and replay between a consumer and an external producer. And that helps you developing locally because you can run Wiremark or you can run Hoverfly locally without the need to spin up all these additional services. And you can typically control the actual service virtualization to much more of a finer degree than you can the actual services. So these are two patterns I totally recommend checking out, all open source tools. Hoverfly itself as well has got a Java DSL, much like Wiremark has. And if you're looking at TCP, Mountebank's interesting, just check that one out there as well. But using the new JUnit 5 stuff, you can do Hoverfly extensions, so you can do record and replay all via the comfort of your IDE and via JUnit. There's a DSL, same thing with Wiremark. You can basically build out, if you look there, you can see like it's a DSL for simulating endpoints. So even if we haven't got a service running yet, we can actually simulate it in our Java code, in our JUnit code, which I think is, for me, has been super useful. Moving on to testing now. So I'm not going to talk about sort of core concepts too much because, again, they're presentations in themselves. But if you're not familiar with things like the test pyramid on the left, there's a reference there to Martin Fowler's stuff. Please do check it out. If you're not familiar with agile testing quadrants, totally worth checking out as well. The big pitch from agile testing quadrants is you're often writing tests that are supporting the team. So those are more of your unit kind of tests. You know, when I say supporting the team, I'm talking about supporting the kind of development team, for example. And you're typically writing some tests to critique the product. And this is more of your end-to-end kind of, BDD style tests. So these two sort of high-level concepts, and these two patterns are really worth looking into. And the actual testing pyramid, agile quadrants, I'm not going to talk about it much, but totally worth checking out. In relation to microservices, a gent called Toby Clemson, working with ThoughtWorks, has done a fantastic article on how to test microservices. He talks about boundaries and running things in memory. So I often use things like HSQL DB or H2 as an in-memory database when I'm testing in Java. I often use things like Apache Cupid for running an in-memory AMQP compliant queue when I'm testing. And this article, it's is the article I wanted to write. It talks about fantastic sort of insights in how you should test microservices, and it's going to cover some of the things I'm going to mention now as well. But that's definitely a reference worth checking out if you're building microservices and you're looking to test. A lot of things around functional testing begin end to end, yeah. And the snag with end to end testing, and I'm talking about sort of manual and automated testing, but a lot of us with end to end testing, we use things like Cucumber, we use things like JBehave and Serenity BDD, and we work with the business and we come up with some kind of executable specification, something in Cucumber or Gherkin, but we treat those tests as if they were scaffolding around a building. And the problem is, a lot of projects I work on, the scaffolding never comes down. And the scaffolding actually hampers us building new things on top. So I'm going to pitch today, for modern architectures, don't think of end-to-end testing as scaffolding. Think of it more as a contract, as a lightweight kind of happy path thing, yeah? If I'm building a microservice e-commerce shop, my happy paths pretty much involve, can I browse for products? Can I search for products? Can I add products to my shopping basket? And can I check out that shopping basket? If I can't do any of those four things, the business is not going to be happy. The business is going to be losing money, yeah? So I typically would write some BDD style tests that I could then execute against my microservices, my application, as a kind of contract, yeah? And again, I generally go for that happy path just because it's easy to maintain. You can do more complex stuff as well. But think about these things more as a contract, less than scaffolding. And so I did a blog post actually on Spectre Labs about this on the left. You can see about how we've approached with a bunch of clients we're working with, how we've talked about, or how we've actually built, I should say, microservices using sort of the outside-in principle. We work with the business, we come up with specs. We use quite often Serenity. If you haven't seen Serenity, it used to be called Thucydides, but they changed the name because no one could pronounce it, myself included. But John Smart, who's very active in the Java space, he wrote the Java Power Tools book. John has written with a bunch of other people open source source tool called Serenity. And I often sit down, or my team and I sit down with the business, we come up with these kind of given when then rules, we codify it into Cucumber, we codify it into JUnit, and it's a great sort of way to start building the functionality outside in. And then we build microservices to support all this good stuff using these things that are continually running in our continuous delivery pipeline. Serenity has got some fantastic integration into things like Jenkins. It does screenshots of your applications and stuff. You can see a little bit on the image on the right. It's just a fantastic tool in the Java space, I think. So I want to reiterate the point again. The reason why a lot of end-to-end testing is kind of shied away from is it becomes too much like scaffolding. It becomes too constraining. Think of it as a contract. Think of your end-to-end tests as happy path contracts to what the system should do. Yeah. And on that notion of contracts, we sort of talked about earlier on with our multiple pipelines here, our multiple apps, and often the choices are, you know, do we do the thing on the left? We gate everything together. Do we do the thing on the right where we've got independent deployment? And obviously with independent deployment, think of the contracts between the two services, between or two or more services. This is where I think things like consumer-driven contracts are super useful. So again, in our pipeline, we're building APIs. APIs are effectively service contracts. And Martin Fowler's got a great blog, I think I've got the link here actually, talks about consumer-driven contracts. If you haven't checked them out and you're building microservices, totally worth a read. It talks about, you can see the consumers on the bottom, say they may be like, you know, 3 Java apps or whatever. They all have different requirements from a producer, and you can basically put into your build pipeline this kind of automated process of verifying that the contract you want as a consumer is being provided by the producer. So I'm not going to talk about it lots, but if you're in the Java space, the 2 great tools I found are Pact on the left here and Spring Cloud Contract on the right. Now, if you're going all in the Spring stack, and Spring is, you know, great product, Spring Cloud Contract is amazing. And now, if you're more sort of agnostic, or you've got a few other different languages in your stack, Pact not only supports Java, but it supports Ruby and Go and Python and a bunch of other things. So Pact allows you, say in Java, to define using a DSL the contracts, and you can build stubbed and mocked producers. You can put them into, say, something like Pact Broker, or you can integrate it into your Jenkins, and you can basically continuous delivery pipeline will be continually checking whether the producer is meeting the contract that the consumers are wanting, those kind of things. Spring Cloud Contract has got a groovy DSL to do very much the same thing. Marcin is, I won't try to pronounce his surname, Marcin, but yeah, Marcin's done some fantastic work, and Josh Long talks a lot about this stuff as well. Marcin's got a whole repo, which you can see the link there, where he's given examples of how to do consumer-driven contracts using Spring. These things are really useful for, you know, given a couple of services or more, do the things work together? It saves that kind of integration point at the end of our continuous delivery pipeline. One thing often gets forgotten in my experience with sort of modern architecture is where we're using things like messaging. We're using things like events. I'm seeing a lot of Rabbit, a lot of Kafka, for example, at the moment. Messaging often involves contracts, yeah? So if I've got like a JSON contract here and I change it in my service, you can see there's some subtle differences with this kind of schema. It's very easy to break downstream services. And I won't know about it because, you know, unless it's baked into your pipeline, how am I going to know that I've broken effectively the message contract? So message schema are an API. Now, I've often struggled with this when I use Rabbit a lot. We've been looking at things like Google protobufs to enforce kind of schema for the messages, and that was interesting. I would shout out to Gwen actually from Confluent, and Gwen and Confluent are very heavily involved in Apache Kafka. So if you're using Kafka, this is a presentation to very much watch. And Confluent are creating this, I think I've got on the next slide actually, are creating this way to verify contracts within Kafka. So you define your messaging in something called Avro, which is a interface definition language, and then you can build automatically your Java objects, your Java POJOs from Avro. And they've got a nice Maven plugin that plugs into the build, and they have an open source schema registry where you kind of store your message schema. And again, as we're pushing stuff down the pipeline, we can now, with this Maven plugin, automate the kind of checking of the integration points, or we can automate the verification of the contracts, the actual messages we're exchanging using Kafka. This, Gwen's talk is definitely worth checking out. If you're interested in this space, really cool stuff. As an architect, you always got to ask yourself with these things, as an architect, one of my sort of challenges is it's all about trade-offs. And with these contract verification things, you have to ask yourself, is it worth the cost? That's the main thing. My experience, and it's kind of anecdotal experience, is it's often about trading off trust and communication versus time. If you're working in a small company, a kind of nimble startup, an SME, trust is probably high, communication is good, and therefore the actual creation of the contracts and the maintenance of the contracts can take more time than it's worth. We actually found this in Not on the High Street. We were using Pact. In the end, we didn't use Pact because it was quicker to have conversations and when we were going to change APIs, and it was quicker to do end-to-end tests using, say, Cucumber and verifying stuff in the build than it was using things like Pact. However, for enterprises, things like Pact and Spring Cloud Contract, when the typically trust is lower, just the nature of the game, it's a bigger company, and communication is not so good, tend to be more siloed in an enterprise. So these things, it's all about trade-offs. Think about where you are as a company, where you are as a team. If you are looking at contract verification, the two sort of previous kind of slides will give you references of things to check out. If you're not, well, then you can have a think about more the end-to-end testing, I guess. On this note, so one thing I would mention is around sort of choreography versus orchestration. Now, choreography is your kind of classic microservice thing where the services just call other services to get their job done. Orchestration is more like BPM, where you kind of define a flow of logic using maybe a DSL or something like that. I've actually got some examples on the next slide. I'm seeing people getting more and more interested in things like Netflix Conductor, where you can create like Docker containers with microservices in, or you can create lambdas or serverless kind of things, and you basically knit them together with in this case, a JSON DSL. Netflix have got lots of cool blogs if you want to learn more about this stuff. You can also typically view the actual kind of the flow of logic, like all these things in this graph here come from the definition, and they're basically small Java services or serverless kind of things that work together to do some functionality, to alter some state or do some behavior. There is a whole bunch of tools exploding in this space at the moment. Amazon State, so Amazon Step Functions and Step Definitions, and the state language, Apache NiFi, Camel has been around for ages, Spring Cloud Integration, RockScript. This is becoming a really interesting space at the moment. So if you're looking at doing Lambda and all this kind of stuff, have a think about the choreography and the orchestration stuff. And again, I'll share the slides, lots of references there. Appreciate this is a bit of a brain dump, but I kind of want to get you thinking about like these changes of architecture and how they impact the continuous delivery flow. So back to that slide now. So choreography versus orchestration. So when you're choreographing services, the kind of classic microservices calling other services, you may be doing some events or whatever, asserting behavior in the interactions between them are essential. And contracts are definitely a part of this, I think. If I'm building one service which is dependent on another, I want to make sure perhaps a contract is in place. If I'm orchestrating stuff, I'm probably not so worried about the flow, but I'm worried about the state or the behavior or the output changing. And the individual services I want to test, the individual functions I want to test, but I'm more interested in testing the actual orchestration DSL. What you saw in the previous slide, testing the JavaScript or testing the way I'm kind of together. So think about how contracts play into these kind of things as well. It's super important, changing tack a little bit. You've tested your functionality, you've tested your end-to-end stuff, you've tested maybe using things like Spring Cloud Contract and the Kafka kind of messaging thing, but testing non-functional requirements or system quality attributes. I think non-functional is a sort of funny phrase, but system quality attributes like scalability, performance, security, super important to do in the build pipeline. In terms of architecture, from a Java standpoint, I love SonarQube. So I typically, my team and I always get SonarQube in the build pipeline. There's a lot of information in our books you'll see on the right, and I'll sort of put some extra references there. But things like SonarQube basically enforce our architectural principles. You can basically fail the build if we've got too much coupling or not enough cohesion. Really kind of cool stuff. I talked about BD in action already, but if you're doing things like performance and load testing, Gatling, which is a Scala-based DSL, is amazing for writing kind of scripts in like a very friendly language. You don't have to be a Scala developer, not at all. I'm not a Scala developer, but I use Gatling all the time. Nice DSL for asserting properties, and it's kind of like a new version of JMeter. If you're familiar with JMeter, I actually use Gatling a lot more now, though JMeter is super cool as well. But I put these in my pipeline, I run these scripts on my individual services, and I run the scripts on the application at large as well. few extra references for you there. Security testing, super important. OWASP dependency check should be a no-brainer. I've got a slide on that one in a minute, which we'll go into more depth. But you should be checking your dependencies. So if you're using Maven or Gradle, whatever you're bringing into your application, you should be checking the security implications of those imports. Yeah, and if you're building a container to ship your application, you should be not only checking your dependencies in your application, you should now be checking your dependencies within your container. Because typically with a container, you're bringing in like an OS, basically an operating system. Looking at these things in a few more detail, if I go to the next slide, excuse me, OWASP dependency check, totally worth checking out. It's kind of a no-brainer, yeah. And OWASP do some fantastic work. They're an open sort of consortium that look at things like security, and they do this thing, dependency check. If you can see here on the code, the plugin is like, what, 10 lines of code, and that plugin basically calls out to the National Vulnerability Database and looks at my other artifacts I brought in a Maven to see if there's any known critical vulnerabilities. And when I run it, it gives me a report. You can see here, you can actually see I was building a simple Spring Boot app yesterday, and there's actually a bunch of sort of CVEs, like was it 5 CVEs found. Some of them are old and some of them are known about, and you can exclude them with a whitelist if you're happy, sort of they won't impact you. But it's really insightful to know about the dependencies you're working with and the transitive dependencies. How will they impact you? Simon mentioned about the Equifax thing up front. I definitely think things like Sonar have a big role to play. The software supply chain that Nexus and Sonatype talk a lot about is really interesting, but you've even got to, before that, get your dependencies kind of in order. Yeah, so it's all really super important, and there's many different levels to approach it from. But these things I think are a kind of no-brainer for putting in your Java app. Yeah, 10 lines of code, pretty much as a plug-in there. You get a nice HTML report as well. You can output that in your build in like Jenkins or whatever, and serve it as a website. It gives you more information about the vulnerabilities found, for example. Looking at the more verification of container images, up until recently, I was struggling with this a bit. There's a few open source tools out there, one called Claire by CoreOS, but it was quite hard to run. I did this version of the talk in London about a month ago, and Armin, very kindly came up to me at the end of the talk and said, hey, I've created a Docker container with all this stuff pre-packaged. Top gent. I really appreciate him coming up, and one of the reasons I do talks is to learn from other people, and he basically sort of ran me through what this stuff he's done, and he's made it super easy. You can pop along to GitHub to pull down a couple of containers and run image scanning, say in Jenkins. So you package your Java app in a Docker container, you put it into your Docker registry. Now you can use his container to scan that image. You do need to build a few Go things, I found. So again, I'm okay in Go, reasonably proficient in Go, so I had to build the Claire scanner locally. But if you're not a Go developer, maybe worth sort of reaching out to Armin and see if he can build it for you or something. But once you've built it, then you just basically point it at a container. You can see my screenshot here from a couple of days ago, and you'll notice this is me doing a Docker pull on OpenJDK image, the Java 8 JRE, the Java runtime, and just look at the number of known vulnerabilities in that container alone. And again, some of these are not, crazy kind of vulnerabilities, but again, I think a lot of us are getting a bit complacent with security, so it's good to be reminded of these things. Yeah, good to sort of have things you can go and research further. One thing I get pushed back on a lot is people delaying non-functional requirements to the last responsible moment. It's kind of an agile thing, and it makes sense when you're building functionality. You don't want to build lots of functionality up front when you don't know stuff. You want to learn stuff, and then just before this kind of last responsible moment, you make decisions, yeah, because you've got more knowledge. But the newsflash, with a lot of the cross-functional and non-functional requirements, the last responsible moment is often up front. If we don't think about performance, security, scalability up front, it's really challenging. And modern architectures don't make this easier. Yeah, I think like microservices and stuff. And it kind of leads to this mentality. You see on the right here, people look at it, I can fix it right or I can fix it fast. And the problem is, once you start fixing things fast, often your pipeline pretty much falls apart, or the value of your continuous delivery pipeline starts becoming less and less and less. So my advice to you as Java developers, Java architects, is think about these things up front. Yeah. So wrapping up, hopefully we're not doing too bad on time, actually. That's pretty good. You saw this kind of brain dump slide of the different types of architecture we're working with as Java developers. When it comes to continuous delivery, like if you work on a monolith, cohesion and coupling is enforced at the module level. And again, Java 9 is kind of introducing even more interesting stuff in this space. But continuous delivery should focus on end-to-end functionality. You get your continuous delivery pipeline right in the monolith and you're kind of good to go. Yeah. So when I'm working with teams on this, I provide kind of goals and best practice examples, because once I got my pipeline running, we can almost sort of cut and paste to some degree. And I'm not a big fan of cut and paste, but we can cut and paste JUnit kind of approaches to testing certain things. We can cut and paste security things effectively. Once we've got that single pipeline working, we're kind of good to go. SOA makes it more of a challenge. Kind of coupling and cohesion is enforced at the service level. So continuous delivery typically focuses more on individual service integrity, and they're typically driven by standards and objectives. Microservices take this a bit further, whereas cohesion and coupling is typically enforced at the service API level. So maybe a REST API or a gRPC API or a Kafka API, these kind of things, or Kafka message API. And therefore, CD often focuses on service interaction, be that something like Pact or Spring Cloud Contract, or be that something like end-to-end testing to verify our functionality. But there, I think we have to provide, as architects, more principles and guidelines. We're still, a lot of us are learning how best to encode some of these architectural guidelines in our continuous delivery pipeline. Kind of same, to be honest, with serverless. I've not got lots of experience in serverless, to be honest, but the stuff I have done, you know, the continuous delivery typically focuses on the output and the state. And again, principles and guidelines are better than hard and fast rules, I think, because it's very much an emerging kind of architecture. So appreciate that. Is a lot of stuff coming at you, and I've got a couple more book references in a minute. A lot of my presentations are like this. They're kind of, the reason I create them are to share knowledge, and I'd love hear your feedback back, but they're kind of to get people thinking, to get you thinking. And the stuff that I've bumped into, my team has bumped into, as we've moved from complicated kind of, monolithic systems to complex microservices and serverless systems, we really need to think more about designing and testing with coupling and cohesion in mind. My role as an architect is becoming more about technical leadership than it is about being a super expert in, XML or whatever, It's about recognizing our situation, where we are as a team, where we are as a department, where we are as a company, and then influencing accordingly. And critically, it's about encoding our requirements, both functional and non-functional, into a pipeline. And there is, as I've hopefully shown you, there's a bunch of tools out there in the Java space that totally make this doable, but we have to kind of get outside of our comfort zone. We as Java developers have to look at perhaps a bit more opsy stuff now we're using Docker. We have to look at some other technologies and so forth. Final slide. Final brain dump of material. Christian Poster, got to shout him out. He's helped me a bunch over the last few months. He's doing a fantastic blog series on migrating monoliths to microservices. Please do check out his stuff on the left. Bunch of books I found useful over the last year or so. Got to shout out the guys from Tommy Tribe, looking at testing Java microservices. Alex, obviously, from Red Hat, and Andy from Tommy Tribe. Some interesting stuff there around enterprise microservices, and of course, clean architecture on the bottom right there, I mentioned with Uncle Bob's stuff. So that is it. And thanks for your time today, and keep an eye out for the book when it's out. Thanks a lot.
Awesome. Thank you very, very much, Daniel. And it's amazing to hear someone say so many words without breathing. It's
I'll need to recover now the next hour,
So let's take some questions. We've got a few minutes before we switch over to the EMEA region. So let me take some questions. Any questions in the Abidjan jug, Noli?
Can take that as a no.
No? So while we're working through that, I'll just check the check Slack. And so one of the things that everyone are mentioning is that it's an awesome session, but they really want your slides, because there are so many frameworks and everything there. I think everyone wants those slides. So if you could send them directly to me.
I'll put them on slideshow if that's okay, actually, because
that'll be perfect.
Right?
And I can just link that. That's excellent. Yeah.
Give me like 10 minutes, guys, and I'll do that. So
no problem at all. But no questions on this side other than that.
It's generally a sign of one of my good talks, in that it's a brain dump, and people often get back to me like a day or a week later. And the beauty of vJUG stuff is you can watch this talk back at half speed. On YouTube.
Nice. Oh, we do have a question. Here we go. Do you see this is from Dan Kift. Do you see building applications built as a set of serverless functions as an alternative to microservices, or do you consider serverless and microservices architecture serve different use cases?
Yeah, great question. So I think the answer is kind of yes in some ways. As in, I see some people trying to build entire applications with serverless, and some people using serverless very much as glue code. Yeah, it's kind of gluing things together effectively. And I think both are valid. And what my one concern with building a whole application with serverless, and there's many smart people that are saying it's an interesting idea or a good idea for certain use cases. People like Adrian Cockcroft from Netflix fame, Simon Wardley saying it's a good idea. My one concern is it gets a bit hard to understand sometimes. Yeah, it's a bit like database triggers. Anyone who's worked on database triggers, like, you know, when you do one thing, suddenly an explosion of things happen in the background. And as a developer, I find that quite hard to understand. I often struggle when I think sort of in terms of asynchronous stuff. Yeah, all these things happening, I have to really kind of stop and study it. So I think, yeah, the long perhaps form answer there, I think it's totally possible, but just bear in mind like where you're at as a company. What's your skill level? What's your appetite for risk and all these kind of things? Because serverless stuff is pretty new. Yeah, so I think it can be done, but be cautious.
And yeah, it's interesting actually. If we look at Java 1, what happened at Java 1 this year? You have Azure who are launching their Java support on
super interesting. Azure doing some really cool
functions,
stuff.
is it called?
Yeah, and that's I linked actually down the slide, Simon. So they've got like a whole like local test environment now for Azure functions. They are really ramping up their Java support. Yeah,
and so of course Oracle's FN project.
Yeah, I played with that the other day, and that's super interesting as well. So I've done more Lambda stuff, but yeah, you're right. As in, it's interesting. People like Oracle are typically not super first movers. They're looking at serverless. I think many of us now, it's at least time to have a look at these things, isn't it? And try and get, as developers, try and get our heads around how we can best use it.
Awesome. So what we're going to do is we are now going to switch streams. So if everyone, what we're going to do is I've updated the website. So if you refresh your, actually don't do it yet, because if you refresh, you're gonna drop. So actually, what I'll say first of all is a massive thank you to Daniel. You're a long-term vJUG supporter, and we appreciate your support and expertise on the virtual jug always. So thank you very much, Daniel.
Thanks. It's always good to be
looking forward. Oh, it's our pleasure. Looking forward to having you on the vJUG again.